A very good afternoon to one and all present here. Knowledge is power, information is liberating, education is the premise of progress in every society. So, on this note, I would like to start our today's webinar session. Our today's guest speaker is Mr. Rohit Lala Sir. He is assistant professor in Marwadi University, Rajkot, pursuing his PhD. Sir has contributed in field of education for almost a decade now. He has published many research papers and has conducted various workshops on Six Sigma, time management, leadership, etc. Today, Sir is going to put some light on the topic of how to measure the central tendency and also how to do basic data visualization using StarCraft. I welcome you, sir, on the behalf of Parul University Faculty of Commerce.
Thank you, ma'am, for introduction, and good evening to all. I would definitely thank to Parul University, Ashka ma'am, and whole coordinator team, and special thanks to our dean sir. And with this lighter note, I would start our webinar with measures of central tendency. So I am just sharing the screen. Just uh, notify me whether it's visible or not. My voice is low. I think now it would be proper. Okay.
Yes,
Now
sir.
my
Now it is proper.
okay. So I think screen is also visible, and
Yes, sir.
so obviously why data visualization is important. First question is this. See, basically whenever we see the data, it would be in raw form, but in management or in commerce field, raw data is not much useful. It should be processed, and then we try to make more meaningful data. And top management, we all know they don't have time, they just have to take the decision, so they want a quick representation of overall data. So that's why data visualization plays a vital role. But as I said, or as Ashka ma'am said, that basically the base of every data visualization is measures of central tendency, is mean, median, and mode. So that we will see first, and then we will try to see what are the different ways of representing the data from scratch. So obviously we know what is measures of central tendency. We have heard these words many times, descriptive statistics. Descriptive statistics means the statistics we apply to describe the data in form of mean value or average, which is commonly used. Next was median, the central value, and mode, the repeated value. Even you have heard this words, standard deviation and range. So let's see it very quickly. So mean, as I had discussed, it is just the average of the numbers. So suppose if I am having, or maybe the formula is very simple, sigma xi upon n, and very simple example I am taking. Suppose I am having three numbers, 6, 11, and 7. Suppose if I want to just do the average, I just add it and divide it by 3. So I will get the average of the three numbers, that is 8. So I think this commonly we have studied. And always remember, all the statistics which has a normal average, or if the data is big and which show a Gaussian curve, or you can see a bell-shaped curve, mean would be used, and that type of test we can say it's a parametric test. So mean is also one of the base for advanced statistical analysis. Next was median. See, the next measures of central tendency is median. Median means the middle value, the middle value of the data. It is a positional average. You can also say like that. So median, obviously, see what we need to do. We need to first sort the data from ascending order or descending order, from lowest number to top number or maximum number, and then the central number would be our median. So obviously, like in our example 10 to 26, we have just arranged ascending, and the center of the data is our positional average, or you can say median. This I think commonly you have applied. Mode. Obviously, you have covered this topic also in your studies. The repeated frequencies of our data is known as a mode. So obviously, see in our data set 639666593. So obviously, the 6 is repeated most, or you can say thrice. So for that data, if we can call, mode is 6. Most important topic, variance and standard deviation. Students, many times we know we apply, like suppose if anyone I will ask what is variance, you will say, sir, it's just a square difference of the mean, or you can say from the mean, and standard deviation is just an under root of the mean, or sorry, variance. So that we apply very commonly, but why it is applied, that is important question today. So just see here, I am just showing one example, but before that I want to ask one small question to you all. I am planning to adopt a dog. Can you just suggest any breeds of the dog very fast in chat box? Very fast, different breeds of dog. Kishan has given answer. So Kishan or any of them, can you just, any of the breed? Like, very good, golden retriever. Then, very good, Pomeranian, Chow Chow. Even you can say Saint Bernard and many other. But see now, suppose if I want to adopt the dog, I would definitely compare the heights. And my students have gathered the data in millimeter. Now see here, they have, like you all have given the answer. Same way, the 5 different dogs they have given, they have suggested me. Rohit sir, this is Rottweiler, its height is 600 millimeter. This is a hound, its height is nearly 400. And this is like, you can say, Dutchess hound, its height is nearly very less, that is 180 or something, 170, and so on. So on the basis of it, I need to decide whether I should buy a large dog or small dog. So that we will work on it. So we need to find these 3 things: mean, variance, and standard deviation. So obviously the mean we have seen in our previous slides only. We just have to add all the values divided by the number of the dogs. So obviously 600 plus all the values, these are the heights. I had divided it and I got 394 millimeters. So obviously when I just draw the line on the plot, it would come like this way. This is my mean height. Now see here, when I just see the plot, some dogs have height above mean and some height below mean. So obviously when I just see the distance from mean, some has a positive distance, some has negative distance. So for that reasons, to remove this negative signs, we need to square it, and then again I am considering the average. So that's why we are doing variance. So see here, the same thing I had done. 206 square plus 76 square plus minus 224 square and so on. And I had divided it. So I got some answer, and that is basically known as a variance. Now see, variance is obviously a square difference. Variance is square difference we have done to remove the negative values to get the positive value. But obviously when I do the square, the, you can say, variable millimeter would also become millimeter square. That cannot be applied in height because other things are in millimeter. This variance is in millimeter square. So obviously to underroot it, to get the average or to get the appropriate distance from mean, I have to do underroot it, and that appropriate measure is standard deviation, which is commonly used. So obviously when I do just have applied under root, I got 147.32, and that is giving me a standard deviation. So this, like from below average and above average, this is my range bound thing. This dogs which comes under this both are considered as a normal dog. But yes, some dogs are not in this range. Now that are known as an outlier. Outlier means, yes, they have extreme values. Now outliers are maybe studied for certain purpose, so that outliers are good. But outliers affect the mean. Outliers actually affects the mean. And that's why less outliers would be there, that much normal the data would be. So see here, like in this scenario, Rottweilers are considered very tall dogs because it is not in our range. It is not in our one standard deviation. And same way, our Dutch Hound, the smallest dog, is also very like small. It has a short height. So I need to prefer this dogs. Maybe these three dogs are a normal dog. This was just an assumption to teach you why this study applies. So this was our first topic of the webinar. Hope is it any query or anything you want to ask? Is it clear, students? Should we move to now our data visualization topic? You can reply. Okay, chalo, fine. So now, obviously, we have different types of data. When we plot the data, we need to know what kind of data we are plotting it. So obviously, there are two main categories of data. The first kind of data is numerical data, and second type or kind of data is categorical data. Always remember, numerical data would be in two forms, whether the data would be in discrete or complete, like 1, 2, 3, 4, 5, 6, which is rounded, which would not be on a continuous form. That type of data is known as a discrete data, like number of counts, number of students in a class. They would be complete, 10 students, 15 students, 25 students. But some data would be on continuous basis. Like for example, your measurement of the scale 15.7 inches or temperature, which shows the fractional values. So that can be considered as continuous data. So this both are numerical data and they have different set of graphs that we should plot. Whereas in categorical data, we know now nominal, ordinal, and binary data. Like nominal data is a kind of data which doesn't have any sequence, just are given to categorize it. Maybe roll number of the students, maybe divisions to our class. So that kind of data is nominal data. But some data is ordinal, which shows the rank, but it does not implies anywhere. It can be a number or it can be just a cadre. So that kind of data also, if we plot, it has a different set of graphs. And binary data is simple, yes, no type of data. Or you can say it has a two outcome. So that kind of data would also be plot and it has a different sets of graph. So this way we just have learned types of graphs. Always remember types of data, and always types of data will decide which graph to be used, and it is important. So numerical data, if your data is in numbers, it will show a numerical data. Categorical data can be in number or can be in alphabets, but it will categorize the data. Your roll number is number, but it is just given to identify you, like roll number 1, roll number 2, and so on. No, like roll number 10 is not greater than roll number 1. So that is the kind of nominal data. Sometimes data would be in ordinal data, like ranks, assistant professor, associate professor, professor, dean, vice chairman, chairman, sir. So it just shows the cadre of it. So that kind of data is ordinal data, ordinal data. And the last was binary data, whether you have filled the form yes or no. The two set of answers would be there. So according to the set of data, we need to plot the graph. So just we will identify here what kind of data is there. So obviously this case number is a nominal data. Every patient has a different case number. This is our sender ID. It is again a kind of nominal data. Every sender ID has a different unique value. Type. Type is the kind like where the city came or what kind of disease is there. So here they have AN representing some city, OX represents some city, NU represent some city. So that's why it is representing it. And total time to settle or to recover it. So these are just a duration which has been represented in front of you. And last, claims whether they are settled or not. So yes or no kind of data is there. So this is a kind of data I had considered to plot the graph. So always remember, when this first three type of data is a kind of categorical data, whereas the total time is our numerical data, but numerical also has a continuous value. And claims are settled or not, that is a kind of dichotomous question. So obviously it's a binary type of data, 0 1 or yes no. So this way we need to identify and we need to plot the graph. So for one variable we will learn how to plot the graph. So just see here, if one variable is there and if your data is a kind of categorical data, always remember two options are available. One is bar chart and second is pie chart. So we will see this in mini tab and then we will come back to PPT. So just be with me. Okay, the same data set as which I had represented in front of you, the same data set is there. Now see here, it has many values. So I don't need to drag and see how many values are there. I can just take the idea from doing a descriptive statistics. But yes, there is one problem. We can get the idea of numerical values only. So obviously when we just click OK, you will get overall idea. See here, I am having 521 variables in my data set. No variable has a missing value. Everyone has maybe zero or any value. This is a mean, as we have discussed, the average of all. This is our standard error, standard deviation. Minimum value is 0 in our data set. Maximum value is 59. Quartiles I will explain you when I will explain box plot. But yes, this is a simple thing, a basic analysis we should do when we apply a numerical data. We just try to analyze the numerical data. But yes, we were discussing about categorical variable. So when you were knowing about categorical variable, always see this software as mini tab. I will also show in state graph, but I will show it on later stage. So always remember, when your data is on categorical variable, when your data is on a categorical variable, the two options are available. First was pie chart and second was bar chart. So that we will see to visualize it. So just I am clicking it to pie chart. I'm just clicking type as a categorical data. I'm just clicking OK. See here, a beautiful pie chart has came in front of me. Now pie chart will show me how much approx queries, repeated queries, come from different cities A and B. C. These are the coded values, but I can just get a count if repeated numbers of OX or repeated numbers of BC is more or less. So this idea can be known through pie chart. But pie chart will show me a slice, maybe it is larger or smaller. Sometimes it doesn't show the very minute fractions like this OX or maybe this. So obviously there are many categories. So at that time, try to prefer a bar chart. So just I am telling you how to prepare a bar chart. Just go on graph. See here you will find bar chart above it. It is a simple bar chart. Just click OK. Just enter the variable type. Just click OK. The beautiful bar chart would be in front of you. Now see here, by seeing the bar chart, you will know the maximum category is OX with their count. with their count. The minimum value was nz or n2 with one count. So this way, if the data is categorical, we need to apply, you can see, a bar chart. So till here, any doubts to anyone? Fast, yes, no in our chat box. Any doubt till now, students? Okay, very good, very good. Now we are moving towards numerical data. So if one variable is there and if the data is numerical, see here, if one variable is there and if data is numerical, we have three options. The first option is to plot histogram, and second option is to plot histogram with normal curve. These both are same, but we will see what is with fit histogram and what is the difference between normal histogram. And the second option is box plot. So always remember, when we plot a numerical data, when we plot a histogram, it will give a information about distribution, whether the data is normally distributed or not. But when we plot the box plot, it will show us the spread. So let's see. So this is our same data, only numerical data has been considered here. Just I am clicking it to graph, I am clicking to histogram. See, when you just click graph and histogram, the options are easily available. So when you just click on simple histogram, you will get a variable. When you just click OK, see, this data is not a normal data. This data is not a normal data. Sometimes its frequency is, you can say, having more values, like 0 is repeated many times, whereas other variables are very less. But then also, if I want to know whether the data is, you can say, normal or not, if I want to check that, I can just apply histogram with fit. Obviously, it will show me the data is not fit. Obviously, it will show me the mean value is 9.42 that we have seen. The standard deviation is there. Count was 521. But see here, this portion is not there. So this, obviously, they are having much outlier. But now if I want to do a visual confirmation of outliers, I can do it. So just plot a box plot. But before that, one more thing I want to apply. Just go to states, graphical summary, the same data, just clicks the same data with 95% of confidence interval. It will give me everything. It will give me everything. The summary report of the test. It will give me the normality test of Anderson-Darling. It will just give me the p-value so that I can come to know that data is not normal. It is not evenly distributed in a bell shape. Even not only that, even I can see the outliers that have a maximum range. This is our box plot that we will see now only, box and whisker plots and all other things. So this is important, like we should know this thing. Now the same thing, when I plot the same data in box plot, I come to know about the spread of a data. So see here, when I just click OK, see, my box plot is ready. Now obviously, to know about more about box plot, always remember this blue portion is my interquartile range, or you can say is middle 50% of the data. This is this called whiskers. The lines that are drawn are known as the whiskers. And obviously this is my interquartile range. That is, when I just click on box, that is my interquartile range. And these star values are outliers. These are all values that are disturbing my data. So obviously, as a statistician or as a researcher, I can remove the outlier, or I can just do a modification of the data by taking log or anything. But yes, the symptoms can be known only through the graph. So this was a basic graph that shows us where our data lacks. What is the middle 50% of the data, where it lies? What is our interquartile range? What is our other 50%, or you can say which are the whiskers that are highlighted? And on the basis of it, we can know more. Even in Minitab, you can use this crosshairs so that you can know about middle 50% of the data. You can know about which outlier is where, but very rarely it is used. Now we are moving towards two variable. See, when there are two variable, we should understand there is a concept of dependency that arise. Basic thing is that we need to know whether variable x, that is a causing variable, affects the other variable, that is y. Old school example I want to give, if you remember, that rainfall directly affects to crop yield. More the rainfall, more the crop yield. Less the rainfall, less the crop yield. It was an old school example. But yes, in this scenario, obviously rainfall is not in our control. It is affecting the other variable, that is crop yield. So always remember the independent variable would be x variable, and dependent variable, that would be affected variable, or you can say dependent variable. So it would be represented by y. So we need to know, if there are two variables, we need to know the dependency. And obviously for that we have to use a basic statistical test, that is covariance, correlation, and for prediction we use the regression model. But yes, if two variables are there, we should know which variable is x variable or a cause variable, and which variable is y variable that gets effect of that cause variable. So on the basis of it, we try to plot the different charts. So the first chart, if we know, the above I had explained the type of data, and that is also important. And not only that, you should also know whether the data is numerical or categorical, whether your variable is dependent or independent. So suppose your x and y variable both are numerical. X and y variable both are numerical. We need to apply scatter plot. This is very simple. If both the variable are numerical, we need to apply scatter plot. Let's check in Minitab. Okay. So in this data set, assume that you are manufacturing the coffee, decaf coffee. Now, if you are trying to prepare a decaf coffee, or you are trying to extract the caffeine from the coffee, you should know the threshold limit. So obviously threshold limit is 1%. So if less than 1% is your threshold, then your coffee is said to be decaf coffee. But if it is more than 1%, your coffee cannot be said as a decaf coffee. It is a caffeine content has more. So now see here, both the variables are there. Now simple thing is there. There is a caffeine content which we measure it, and there is an extraction time. Extraction time means how many hours if machine is on, or how many minutes if machine is on, the content of caffeine is reduced. So first we should know whether there is a relationship between them or not. And that's why I always say if there are two variables, you should always apply a basic statistical tool, or you can say formula, that is correlation. Try to measure the relationship between this both. Don't worry, x or y variable. When we just measure correlation, just apply it. So when we measure the correlation, by default Minitab will give us scatter plot. But see here, my correlation is strongly negative. In simple words, more the extraction time would be there, less the caffeine content, and less the extraction time, more caffeine content. So it is having a, you can say, strong relation. And if you want to plot a scatter plot, very simple, just the first one, scatter plot. Try to, as simple scatter plot we have seen when we have run the correlation test, we will see the scatter plot with regression line. But here, when you just plot a scatter plot with regression line, you should know which variable is dependent and which variable is independent. Obviously, extraction time affects the caffeine content. So extraction time is our x variable, whereas caffeine content is affected, and that is our y variable. When I just click OK, see, beautiful regression line is prepared, and on the basis of it, I get beta 0 and beta 1x. So obviously here beta 0, or you can see y plus a into a, y is equal to a plus bx. So a value is my beta 0, which is you can say 0.2099. So at 0 value also the caffeine content would be 0.2099. So on the basis of it, if I just make more extraction, it would reduce the value. So this was a basic two variables, but yes, both the values are numerical. Apply a scatter plot. Next important thing that we need to study is if one variable is numerical and other variable is categorical. But yes, here you need to see which variable is independent and which variable is dependent. Suppose your y variable is numerical and x variable is categorical, you need to just, you can say, prepare a box plot. So now here we will just see a box plot, but box plot of two variables. Okay, see here, this is the different caffeine content, and here the extractor number, or you can say machine given to extractors, or you can say numbers given to the extractor machine 1, 2 and 3. So obviously extractor number is my categorical variable and caffeine content is my numerical variable. So when I just see this both, I need to prepare a box plot. So obviously box plot can be prepared very easily. Just click on box plot, within groups, or you can say with groups, just click OK. Your graph variable is caffeine and your categorical variable is extractor number. When you just click OK, you will get a beautiful graph of three different box plot. See, now you can do a visual confirmation. You can compare all the box plots. Like machine 1 is extracting it, and obviously the maximum of it, like just take the help of crosshairs, the maximum of it or maximum caffeine content is, you can see, only 6.2 or 6.4. Same way machine 2 is also normal. It takes the extraction and it just like below 10, nearly you can say 0.94. So this both machines are proper. But when you see the third machine, see, this is extracting, and the machine or extraction from the sample is bit high than 10. So you can see the maximum number of the rejected coffee beans would be considered from machine 3. Now see, as a quality engineer or as a statistician, you have given the symptoms that machine 3, when the extraction is done, obviously it is not at per the mark. So you need to recalibrate the machine, or you can say the basic servicing is required. That can be known through it. So always remember, if one variable is categorical and another variable is numerical, and also we should know the dependency, that is our y variable is numerical or dependent variable is numerical, and x variable is, you can say, categorical. So in this scenario you can plot a box plot and can compare the different outcomes of the data. Next important thing, reverse scenario. My y variable, that is dependent variable, is categorical and x variable is numerical. Then also I have to prepare a box plot. But yes, it would change my dimension. So that's why I need to transpose my box plot. So just let's see that kind of data. Let's see that kind of data. So I am just clicking it down. See this data. Here maths grade is there. That is my numerical variable. And on the basis of maths grade, whether student is clearing the exam or not, that is decided. So obviously pass or fail is my categorical data. So that is important. That is important. Like suppose maths grade is 7, obviously student is not passed. But again, if it is maybe 9, student clears, and on the basis of their grade, student has cleared the exam or not. So my maths grade is x variable, pass or fail is y variable. And obviously, if I want to see it visually, I need to prepare a box plot. Obviously, it's within group box plot because two variables are there. My graph variables would be, you can say, maths grade, and my categorical variable would be pass or fail. But here, when you want to transpose your box plot, you need to click on, you can say, scale. When you click on scale, you need to click on transpose value. When you just click OK, see here your box plot would be there, but it would be horizontal. Sorry, horizontal, not vertical. And on the basis of your grade, whether the student has cleared or not, that can be measured. So this is, you can say this way, 50%, 7 is your central value. If he gets more than 7, students has cleared the exam and so on. So this way the data is represented if, as I said, the data has two variables and one variable, that is maths grade, a numerical variable is our x and categorical variable is y. Last, obviously, variable is again, if suppose both the variables, see condition, if both the variables are categorical, then we have two options, whether we can plot a stack bar chart or we can use the cross tabulation. So let's just see the data type. See here, there are three doctors, that is P, Q, and R, and two departments, A1 and A4. Now suppose this both are categorical data. We cannot just find out the counts by clicking a basic statistics and graphical summary, or you can say display descriptive statistics. First thing, if both the data is categorical, you need to prepare a table, and that table is known as a cross tabulation. Just click on cross tabulation. You can prepare row of specialist or department, there is no issue, and in column you can prepare a department. You can also get in table the counts, percentage, column percent, and total percent. Even you can do advanced study, you can apply chi-square test on it, but obviously that is to be considered when we do a more detailed analysis. First we will see how cross tab is prepared. So just click OK. See here the cross tab is prepared, and on the basis of it you will get all the things. You will see the total value is 269, and on the basis of it there are different things that has been described. So this way also we can get a visual summary of a data, but yes, I cannot get a visual graph of it. So that's why to plot a graph, I just have to, obviously both the data are categorical data. We can always plot bar or pi. See, pi is not possible. So always, if two variable is there, click on bar, click on stack bar plot, just click OK. Just enter both the variables, click OK. A beautiful bar chart would be prepared. And now you can see this blue color data is our department A, and red color data is, you can say, department A4. And on the basis of a doctor's visit, that is P, Q, and R, we can visualize it. Not only we can visualize it, but we can also see it by the help of crosshairs. So this four important things that we should remember if two variables are there. I would also add one more example of Pareto chart, but till now, students, any doubt? Till now, any doubt? Fast, yes, no? Chalo, very good, very good. Now, I want to show one important thing. There was one bakery. There was one bakery, and in that bakery, there were frequent stoppages of the oven was found of. And due to that frequent stoppages, many of the, you can say, electric bills were too high, because when oven is stopped and when it is restarted, and that bakery oven is not like our home's oven, it is an industrial unit. So once it is stopped, it is cooled down, and again we restart it, it consumes more energy. So there were different causes that we have studied, and due to that many different causes were came out of it, and that causes were deviation and dimension, break, problem with dough, again maintenance of the oven, problem with knife, even deviation in dimensions of the toast. Sometimes oven is out of order, so biscuits stick on the oven conveyor belt. So this all things were found from the person they work on oven, so that were measured on it. And obviously two different things were there. First important thing was stoppages, why that machine stops, that reason or number of times that machine has stopped. And second was duration of the stoppage, like why this machine, how many duration, 30 minutes or 45 minutes, that we have measured in it. Now suppose I want to do an analysis. So obviously if more problems are there, you need to refine that problem, and that's why you need to apply a Pareto chart. So obviously Pareto chart would be found in quality tools. When you just click Pareto chart, obviously the defects or attribute data would be our cause, and frequencies would be a, you can say, duration, or stops you can just apply here. When you just click OK, say here the problems that you find out. Say here the problems that you find out. Maximum of the problems are caused by these three reasons only. That is due to deviation in dimension of the toast, due to workers are taking more break, due to problems with dough. You can see 80% of the problem is led due to this 20% only. So you can control these problems, and on the basis of it you can reduce your inputs, or you can say you can reduce your efficiency, increase your efficiency by reducing the breaks or reducing the stoppages that incurred a huge electricity bill. Same way, this was on the basis of the stops, the number of stops or counts. Suppose if I want to analyze it on the basis of duration, so same thing here in Minitab you have option. The same thing can be seen or clicked. When you click it, the last step would be run again. Now here you will just replace stops with duration, and when you click OK, you will have a different graph, and you will find out the more number of time your oven is stopped due to these four reasons, breaks that we have seen in our previous graph also. Dimensions, or you can say deviation in dimensions, the shape of the toast, or oven out of order. So here the owner of the bakery should take care why that breakdown is occurring, and obviously problem with dough. So this way we can do a basic analysis. Okay. So this was a basics of data analysis. Um, I would like to show some more analytics. So just give me 2 more minutes. I want to show just 1 minute. I am stop presenting it. I I want to show one important plot or data visualization that can be easily done in Minitab. So just 1 more minute. I think screen is again visible now.
No, sir, it's not visible. Yeah, now it is presenting.
Okay. So this is one more data set of cause and effect diagram, and that can only be made, or you can say easily made, in Minitab. So many times, no, as I have said, there are different problems that arises, and while doing a brainstorming, we have to use some tools. So this is one of the best example that I like. Uh, Cause and effect diagram is a kind of a quality diagram again, but yes, it is more used And many of the problems we discuss for any you can say event that would have these three factors that affect, that is man, method, machine, material, even measurement and environment. And there was a problem while they have launched the 2G tower. If previously, before 10 years, there was not a 3G, there was evolution of 3G that has came, but before that there was a 2G spectrum. And in 2G spectrum, many problems were there. Many times, no, when we just talk, the phone was disconnected. Due to some other factors also, we were not getting a proper network. Nokia phone we were using it. So at that time, we have like the companies, the service provider companies, try to identify the problem and had done a brainstorming on it. So they found that driving, they are like if customers are driving and talking on a phone, that would obviously get a less network and phone can be disconnected. Wrong numbers was also one of the problem, and that is due to men's error. Method, obviously sometimes operators do the error, sometimes phone drops, sometimes due to building or inside the building, if person is using the thing or using the mobile, that was having less frequency, that was wrong method to adopt or use the mobile. Machine, obviously machine factors were like old machine instrument. Sometimes network is deflected due to tower or many other things. Battery failure, battery dead, distance from tower, that is a measurement problem, and environment, that is weather and obstruction. So these are the outcomes of the problem from doing a brainstorming. So when anyone or when a management does a brainstorming and they get a different outcomes, then obviously that problems can be represented in a beautiful graph. So obviously the persons or personal, you just have to click on man. Machine, obviously you just click on machine. Material, just click on material. Method, just click on method. Measurement, just click on measurement. And environment, just click on environment. This beautiful graph was developed by Kovra Ishkwa. He was a quality engineer, and it really helps many of quality engineers to work on it. So obviously, when environment is there, there is a subcategory, that is, you can see weather. So you just have to click here, weather. Even at obstacles, you just have to add obstacles. So when you just click OK, here you need to give a name of it. Just click OK. See, a beautiful cause and effect diagram is there. So these are the reasons of the cause, and due to these reasons, it impacts on a mobile signal. So many times, no, if data is categorical and if we want to summarize it and make a picture, this kind of graph is used. So hope it is clear visible. I had set the data sets to mem, and you all can practice it. Minitab, you can download and practice it, so you can work on it many times. No, if we work more, you will get more idea about it. Now, students, I will show you one software that was Statecraft. Obviously, Statecraft is a wonderful software. Um, Anyone is aware about R Studio or R? Yes, no? R Studio or R? Chalo, no issue. If you are not aware, It's a coding program. Just give me 1 minute. A kind of a coding program, and to code in our studio is bit difficult. But Statecraft is a software that helps us by just generating the codes. Like as I am using Minitab, no, same way. It is a kind of software which has fine, you can say, visual tabs available, and on the basis of it, this software is online. You can say it is a cloud-based software. So, like I had entered the data previously, I will show you how to enter the data also. So don't worry about it. This kind of data I had entered, and I can work on this kind of data set. So obviously, I had prepared one X variable. I can just do a basic statistical analysis by clicking on descriptive. I just need to give the title Rohit. Obviously, I just need to enter the variable and what kind of descriptions or what kind of descriptive analysis I want, that I need to add. So just 1 minute. It is a very nice software. I will just show you. Just click OK on mean, median, standard deviation, variance, range. Range means lower, highest value minus lowest value, minimum value, maximum value. Obviously, skewness and kurtosis are also found of. So that all things can be whatever things you require, you can just click OK. When you just click OK, see here, this is kind of R code that prepares and it gives me other things. But obviously, uh, not only that, the calculation would also come in this kind of beautiful table. See, mean of the data is 4.4, median is 5, standard deviation is 3.062, variance is, you can see, square of standard deviation. Minimum value is 0, maximum value is 9, and range would be 9 minus 0, that is 9. So this way also we can do the analysis. And dear students, software is just a tool. Don't stick to any software, just learn the methodology, interpretation, so that any software or even you can calculate manually and can get the idea. So this way you can also prepare a bar plot of this data. I will show you how to prepare the bar plot. And obviously advanced tests can also be applied, but yes, we have just discussed about measures of central tendency and basic graphs. So we just will see a basic graph of the data, that is